Okay, so let's start with the power supply. This is a 48 volt toroidal power supply that I bought from Automation Technologies. And you can get different power supplies. Most of them don't look like this. Usually they're in a kind of a cleaner looking enclosure, but regardless of what type you buy, they essentially do a lot of the same things. In this case, it's 48 volts, so it has plenty of juice to drive all 3 or even 4 motors at once if I end up going to a 4th dimension on it. It has these extra large capacitors that help to smooth out the power. And this one has 2 types of power. So it has the 48 volt on this side, the high voltage output, and then on this side it has a 5 volt output for driving electronics or fans or things like that. So this is the power supply, and I'll go into how to wire it up in the future video, but it is relatively simple using the 120 volt power that we have here in the States. If you're on 220 someplace else in the world, then there's a little bit different wiring that you have to think about, but I'll go into that as we get to it. So moving on from that, one thing that I am putting into my circuit is a circuit breaker. I'm not sure if this is really the best one to use. This is just a normal circuit breaker you can buy from Home Depot or Lowe's. I bought this one at Home Depot. It was just a few bucks, and this is a 15 amp. Nothing that I'm doing here uses 15 amps, so if it gets to the point where it's tripping this circuit breaker, something's gone seriously wrong. I've thought about maybe getting a with lower amperage, but for right now this is the one that I have. The power comes from the wall, comes into this, comes out, and what you have to be able to do is, ultimately you want the power to go to the motor and you want to be able to control the motor, but before you can get there, you have to have a motor controller. So the motor controller that I have here is a Kelling. This is a KL8056 digital controller. Now, one thing I want to say about digital controllers is that you can buy analog. The analog ones are a little bit cheaper, but I've chosen to go all digital with my system because, listen, it's 2017. We're not going back to analog. Everything is going toward digital, and I'd rather not have something that is going to be obsolete just coming out of the gate. So everything that I'm doing here is digital. I thought about putting in the parallel system and going analog, but the money savings wasn't worth it. And I think that as we go forward, you're just not even going to be able to buy analog components. So I went ahead and bought this, and I have 3 of these, and I'll go into how to wire this up as well later on. But that's what this is. So what this is going to do is it's going to take power from the power supply. It's going to take digital signals that come in from the breakout board, and it's going to drive the motor. And that's what these ports are for here. But we'll go into the wiring later on. Now, in order to get the signal from the computer to the motor controller, we have to use what's called a breakout board. Now, again, you can go analog with these things and save some money. I think maybe this would be where you would save the most money. But this one has a couple of features that I want to go over. It has a lot of capabilities, too much for one video, but one of the things that I like about it is that it's driven off of a USB connection. So obviously this is more something that you're going to be able to support going forward. You'll see that some of the breakout boards that you see online are still driven from parallel ports. There are people who are going to take the position that analog and parallel ports are better because they can isolate signals on pins and things like that. It is kind of interesting and fun to play with the pins, but to be honest with you, I think that this is more the way things are going. The other thing that this breakout board has, oh, and by the way, this is a PMDX 416 Smart Bob breakout board. If you want to take a look at this, go to pmdx.com and you can see this one as well as several other models that they make. Again, as time goes on, they just keep making these things better and better. So other than being digital, the other thing that I like about this is that it's opto-isolated. So in the event that there was some sort of a power surge that came back short or anything like that coming back from the motors and the motor controllers, what happens is this is opto-isolated. So all the signals, there's actually separate circuits for the signals that go back and forth to the computer versus what goes to the motors. So if there were a power surge, if there was some sort of a problem in the electricity, this might fry out, but the surge would not travel back up into your computer and wipe out your computer. So that's one of the other things. Now, it does cost extra to get that. I've seen people claiming that they're getting breakout boards for $15 or $20. This one was significantly more than that. But think of it as an insurance policy. I don't think that you're going to get digital ones for that much cheaper anyway. And the opto-isolation is just pretty important from that perspective. Now, finally, we have the motor here. Now, I've put a piece of paper on here because later on when I hook everything up, you'll be able to see this spinning. This is a NEMA 23. I believe it's made by Kelling as well. This is 570 ounce inches. I'll be using this for either my X or my Y axis. I have a larger one that I'm going to be using for my Z axis. And so that's the one that I have for this. You can probably go a little smaller than this. You can obviously always go bigger. But I think that this is the one that I think almost everybody uses for the G0704 mill. So those are the primary components that you need. Now, keep in mind, you're going to need other electronics components ultimately. But in terms of just taking a signal from the computer, coming in from the from Mach, and being able to translate that into actual movement of the motor, these are the basic components that you have to have for that. You're going to want to have e-stops and all kinds of circuitry to kind of keep things safe and give yourself some feedback in terms of amperage usage and things like that. So we'll go into all of those types of components later on as we get into it. But for now, we'll keep it simple, and I'll show you how to wire this up in the next video.